As I mentioned, 700 miles west of the Cape Verde Islands. The center located at 15.0 north, 34.0 west. Now, should this strengthen into a tropical storm, as long as no other storms get named until this time, this will be named Cindy. Now we'll go to the central part of the Atlantic, show you, and put this into motion for you. Here's that depression off the coast of Africa, tracking toward the west. Elsewhere, pretty quiet, although we're seeing massive thunderstorms here just north of Panama, but we see those dissipated quite a bit. Into the Gulf of Mexico we'll go. We'll show you pretty quiet, except for the northwestern Gulf of Mexico. Tropical storm Lydia, there it is, 520 miles west-southwest of Acapulco, moving to the northwest at 13 miles per hour, and the indicated position there. We'll go even further to the west. Typhoon Dinah starting to recurve back to the northeast and accelerate to the northeast. A minimal typhoon right now. It's going to be bringing some heavy rains to this part of the world.
The following is a special presentation of the Weather Channel.
The beach, a place of such beauty and peace that tens of millions of people are drawn to live here. And in the warm months, tens of millions more come to vacation. This is the beach at Galveston, Texas, and it probably looked something like this on September 7th, 1900. But a day later, a powerful hurricane put the level of the water on this beach to a point 15 feet over my head, higher than this seawall built later for protection. 6,000 people were killed. It was the worst natural disaster in U.S. history. From a distance, a hurricane looks like a work of art. A radar on the ground shows geometric circles and spirals. An astronaut sees a similar sight of breathtaking beauty. And a satellite 23,000 miles up also shows nature's art. But underneath, inside the storm, turns into terror. Hurricanes aren't the biggest storms on Earth or the most violent, but the combination of size and violence is unequaled in nature. One day's energy production in a hurricane, if it could be converted to electricity, could provide power for the entire country for 6 months.
Good evening, I'm Colleen Wine. What if you and your family were on a vacation on the Gulf or somewhere along the Atlantic, and you found out that a hurricane was headed in your direction? Would you and your family know what to do, where to go? How about if you live in Florida? Chances are you'll go through a hurricane at least once in your life. Well, coming up this hour on Eye of the Storm, we'll be discussing hurricanes and answering your questions about what you can do to save your life and property. Here to answer your questions, representing the American Red Cross disaster relief efforts, Don Stevens. Don is currently the Hurricane Watch Team Director for the state of Georgia and the Director of Disaster Services for the Metropolitan Atlanta chapter. His first Red Cross disaster assignment was Hurricane Camille in 1969, a kind of trial by fire. He's directed the disaster relief for hurricanes in Georgia, Florida, Louisiana, North Carolina, South Carolina, Alabama, and Mississippi. He's experienced in handling disaster operations, supply, mass care, shelter operations, and food supplies. Welcome and thanks for joining us, Don.
It's good to be here. Thank you.
Our expert on civil defense is Wade Geis. Wade is the Director of Civil Defense of Harrison County and the city of Gulfport, Mississippi. As such, he played a vital role in the emergency operations during Hurricane Camille, Hurricane Betsy, Hurricane Frederick, and Hurricane Elena. Because of his expertise in public safety, he was loaned to the State Department to make an on-site, in-depth survey of Saudi Arabia's national civil defense posture. He was national chairman of the Natural Disaster Committee of the United States Civil Defense Council and served on President Nixon's advisory board on natural disaster. Wade currently serves on the Board of Visitors with the National Training Institute and also serves as a visiting faculty member. Thanks for making the long trip from Gulfport,
Thanks
Wade.
for the invitation, Colleen.
And last but certainly not least, our hurricane expert from the Weather Channel, John Hope. John began his career in the Air Weather Service during World War II. Later, he was with the Space Flight Meteorology Group and was senior hurricane specialist at the National Hurricane Center. He's received many awards and honors. He led the World Meteorological Organization's Pacific Typhoon Committee and review mission to Asia, and he represented the United States at a global typhoon conference in Bangkok. We're proud to say he's now the Weather Channel's hurricane specialist. Thanks,
Thank you, Colleen.
We'll be giving you toll-free numbers in just a few minutes so you can speak with Don, Wade, and John. And of course, throughout the hour, you'll be seeing your local forecasts. Up next on Eye of the Storm, we take a ride through a hurricane. That help create hurricanes. How those elements fit together to form the world's most destructive storms is the subject of our next segment. Here's Glenn Schwartz.
Hurricanes form only over the warm tropical oceans, near but not at the equator. Several form in the Atlantic each year and either curve away from the coastline, hit the U.S., or continue into Central America. Now, even more form in the eastern Pacific. A few of these strike the Mexican coast, but most move away from shore, like this one. A rare hurricane can reach as far as Hawaii, though. Look at what Hurricane Eva did to the island in 1982. Huge stretches of warm Pacific water allow lots of storms to form. The name is different. They're called typhoons here when winds reach 74 miles an hour, and there are more of them in the western Pacific than any other place on Earth. They often hit Southeast Asia and tend to be the biggest and strongest anywhere. This one is getting dangerously close to Japan. They're called cyclones south of the equator over here, and Australia occasionally gets hit by one. As you can see, they spin the opposite way from storms in the northern hemisphere, but are otherwise the same. Cyclones also form over here in the southern Indian Ocean. Back north, we find a few cyclones in the Arabian Sea. But the deadliest storms on Earth, also called cyclones, form in the Bay of Bengal, where even weak cyclones can lead to disaster. In 1970, a cyclone struck Bangladesh, killing an estimated 500,000 people. But hurricanes don't just cause death and destruction. They exist for a reason.
We begin to see this tremendous buildup of heat in the tropics. You got to get rid of it. Well, nature's got a very effective way of doing that, and it's called the hurricane. Hurricanes are bad enough, but if we didn't have hurricanes, we might have something even worse.
Our hurricanes often are triggered by disturbances that form over Africa. About 100 disturbances move across the Atlantic each year between June and November. Yet an average of only 6 develop all the way into hurricanes. There are 2 other sources for hurricane development. One is from a persistent band of clouds north of the equator called the Intertropical Convergence Zone. Sometimes a patch of clouds breaks off, moves north, and forms into a hurricane. The other cause is an old front that has moved through the U.S. and stalled in the warm waters. After a few days, a large mass of clouds can strengthen into a hurricane. How does a mass of clouds form into a hurricane? Well, the exact process is very complex and not fully understood, but we can demonstrate some of the principles in a kitchen. We know that hurricanes need a heat source, an ocean temperature of around 80 degrees Fahrenheit or higher. That heat ends up in the air in 2 ways. As we warm this pan of water, we can feel the heat rising into the air well above the water. That's the first means of heat transfer. The other way can be seen by watching the water for a long time. It gradually disappears, but it hasn't really disappeared. It's evaporated into the air. The energy that went into evaporating the water also goes into the air and is released later as heat when the cloud droplets form, or in this case, the water droplets in the mirror. In a developing hurricane, the pressure at the center falls as the warm air around it rises. Surrounding air then begins to move toward the lower pressure. The Earth's rotation causes the air to spiral around the low, counterclockwise in the northern hemisphere. Another obvious question is, why do so few low-pressure areas in the tropics become hurricanes?
It takes a special, unique combination of a number of different events, apparently, for the tropical storm or the hurricane to form.
That precise recipe of winds, clouds, and temperatures is only reached occasionally. Once it develops, the most unique and easy to identify feature of a hurricane is the eye. It's an area of no rain, light winds and few clouds produced by sinking air. It usually ranges from 15 to 30 miles across. The lowest surface air pressures are found here. Surrounding the eye is the eye wall, a towering cylinder of clouds 8 to 10 miles high. The air is rising rapidly, and the heaviest rain and strongest winds are found here. A plane flying through the eye and eye wall shows the incredible contrast between the two. Much of a hurricane's energy is concentrated in the eye wall. Away from the center of the hurricane, we can see the spiraling of clouds around it. Under the clouds, spiral bands of heavy rain and strong wind gusts can cause brief bursts of stormy weather hundreds of miles from the eye. The entire area affected directly by a hurricane is often several hundred miles across, with the area of maximum destruction about 50 miles wide. In contrast, a tornado, represented by the dot, would affect only a small fraction of the area. A three-dimensional view shows another part of the structure of a strong hurricane, the upper-level wind outflow. If air blows in near the center, then rises, it has to go somewhere. So at high levels, air needs to be blown away from the eye wall. Let's take a trip through the hurricane now as I shrink down to the size of a particle. Gentle winds are carrying me closer to the storm. I'm now crossing a spiral band. The wind picked up and it's raining hard. Now it stopped and the winds are lighter. Here it goes again, another spiral band. Now as I get closer, the wind and rain are becoming stronger. I've now been carried into the eye wall, experiencing the full fury of the hurricane. The winds and seas are incredible, and I'm being carried upward, fast. Now I'm reaching the top of the storm, and the upper level flow is turning me the other way, clockwise. I'm being blown away from the storm, and the winds and rain have let up. And now I've been thrown hundreds of miles from the eye. What a ride.
Our meteorologists are continuing to prepare your forecast here at the Weather Channel, where we will be taking your phone calls in just a few minutes. Up next, your local forecast, after which we will be taking a look at what kills 9 out of 10 people in a hurricane. A hurricane are caused by drowning. Drowning in a mound of water known as a storm surge. Once again, here's Glenn Schwartz.
Satellite pictures prove that no two hurricanes are alike. Some are much bigger than others. Some produce more rain. Some have bigger eyes. Some have their spiral bands concentrated on one side. There are differences in intensity, too. Hurricanes are measured on the Saffir-Simpson scale, which ranges from 1 to 5. A 1 is a minimal hurricane with highest winds barely 74 miles an hour. A 5 has winds over 155 miles an hour. But even the wind of a Category 5 hurricane is not the most dangerous aspect of the storm. The biggest threat is water. It's hard to imagine that something as peaceful as ocean water can turn into such a killer. But water is extremely heavy. A cubic yard of it weighs nearly a ton. Imagine winds pushing that ton of water along at incredible speeds. Multiply that by the millions of cubic yards of water out there, and you have phenomenal power. Power in a killer called the storm surge.
9 out of 10 people who die in a hurricane drowned in the storm surge. Now, this is a dome of salt water, maybe 50 miles wide, that sweeps across the coastline near the point where the center of the eye makes landfall. Now, on top of that dome, you have wind waves. 5 and 10-foot waves that come crashing at the shore.
The storm surge is a mound of water partly created by the low pressure in the eye of a hurricane. I've lowered the pressure inside this straw by drawing air out of it, and the level of the liquid rose. The same thing is true on a much larger scale out in the ocean. And the level of the ocean water can rise a couple of feet above normal this way. Since an actual storm surge has never been filmed, we'll have to simulate it. On a given day, the tidal level comes up to the blue line with small waves on top. As a hurricane approaches, the water level gradually rises, perhaps a few feet. The water level rises rapidly when the storm surge hits, usually near landfall, that is, the time when the eye reaches the coast. It might rise 4 feet in 4 minutes or even faster. Let's say the total storm surge adds up to 10 feet with huge waves on top. The final water level varies according to 3 main factors: First, the tides. The moon's alignment with the Earth and Sun actually plays a role. Some places have huge differences in height between low and high tide. Our sample storm at low tide might raise the water level only 4 feet, while at high tide, the total would be 16 feet. Second, the shape of the ocean bottom. Deep water near the coast means a smaller surge, perhaps 4 feet instead of 10. Shallow water would cause a much higher surge, perhaps up to 16 feet. This is why the same storm causing a 15-foot surge on the Florida East Coast would cause a 25-foot surge on the west coast of the state. The third factor is the shape of the coastline. As this demonstration shows, a straight coastline produces a certain surge. But the same wave hitting a concave coast produces a much bigger surge. It is the combination of high tides, shallow water, and a concave coast that led to the catastrophes in Bangladesh. Look at what storm surges have done in this country. The surge of the 1900 Galveston hurricane put the island completely underwater. Structures that looked safe ended up as flat as the shacks. More recently, Camille's surge in 1969 reduced the Richelieu Apartments back to its original concrete slab. After the storm surge, wind is the second most dangerous aspect of a hurricane. Buildings that might survive 100-mile-an-hour winds can be blown away at 200 miles an hour. Even heavy objects can become deadly missiles. Each doubling of the wind speed increases the force of destruction 4 times. So the destructive force of a 200-mile-an-hour wind is 100 times greater than the force of a 20-mile-an-hour wind. Another hurricane danger can be tornadoes. The twisters tend to form just ahead of hurricane landfall, but are weaker and don't last as long as Midwestern tornadoes. Once a hurricane makes landfall, the energy source is cut off. The warm water isn't there anymore. And as you can see by the eye filling in with rain, the storm loses its structure. But the total rainfall often increases. It's hard to measure hurricane rain because it blows sideways and often misses the rain gauges. Rains up to 30 inches have been measured, resulting in disastrous flooding. Agnes was a minimal hurricane when it hit Florida in 1972. It then weakened even more, but stalled over Pennsylvania and New York, dumping up to 20 inches of rain. The resulting floods caused 122 deaths and billions in damage. Let's now look at a sample hurricane from 3 different locations in its path. Imagine Hurricane Zelda approaching a straight coastline, moving 10 miles an hour. A 200-mile wide area has been evacuated because of the threat. We'll look at points A, B, and C along the coast, 50 miles apart, and watch their winds and water levels. 24 hours before Zelda hits, all have 10-mile-an-hour winds and normal tides. 6 hours before landfall, A has 20-mile-an-hour winds from the north and a 3-foot rise in water level. B has 25-mile-an-hour winds and a 5-foot increase in water level. C also has 25-mile-an-hour winds from the southeast and 5 feet of water. The conditions continue to worsen until the eye wall hits the coast. A's winds are now 50 miles an hour, but since they're blowing offshore, the water level is now below normal. At B, the wind has increased rapidly to 160 miles an hour with a 16-foot rise of water. And C has 70-mile-an-hour winds and an 8-foot increase in water level. A half hour later, A has 50-mile-an-hour winds and the water is still below normal. B is in the eye, 10-mile-an-hour winds, but a high chaotic water level of 16 feet. C still has 70-mile-an-hour winds and an 8-foot water level. But the worst part of the storm is between B and C. A wind of 190 miles an hour from the south is added to Zelda's 10-mile-an-hour forward motion. So the total effect is a 200-mile-an-hour wind with a peak storm surge of 20 feet. A half hour later, A's conditions haven't changed much. But at B, the wind has increased rapidly from the opposite direction, and the water level is still high. At C, winds and water levels are decreasing. The worst of Zelda is over.
Still to come on Eye of the Storm, would you and your family know how to survive a hurricane? We're now taking your phone calls at 1-800-327-0945 or in Georgia, 1-800-338-6280. Stay with us. Longmeadow, Massachusetts. You're on the air. What's your question, please?
Hi, how vulnerable is New England to a major hurricane?
Okay, we'll give that one to our hurricane expert, John Hope.
Well, they're certainly very vulnerable to a major hurricane. Fortunately, they don't have all that many, but they've had some very disastrous ones. They had one in 1815, and the next major hurricane they had was 1936, but then they had a whole spate of hurricanes, 1938 rather, 1938, 1944, a couple in 1954, and finally Donna in 1960. Now, one thing about a New England hurricane that we need to understand is to come into New England as a major hurricane, it's got to be going very fast after it gets north of Cape Hatteras, because if it doesn't, the trip over cold water is going to make it weaken. Now, it also makes a big difference in New England whether it comes in on high tide or low tide. The big difference between Hurricane Gloria and the hurricane of 1938 was that 38 came in on high tide, whereas Gloria came in on low tide. And you can see by the time you get up around New Jersey and New England, you're talking about a difference of 8 or 10 feet between the normal high and the low tide.
Okay, real good. So really the water temperature could be, if the hurricane is moving slow enough, then our water temperature could really diminish the effect of the hurricane.
It gets very cold quickly north of Cape Hatteras, so if the hurricane is moving slowly, it weakens. If it's moving very rapidly, it doesn't have much time to weaken.
Okay. I believe we have another phone call. This one's out of Athens, Georgia. You're on the air. Do you have a question?
Yes. What are some of the reasons we're not having hurricanes form in the Atlantic this year? Is it because of lower water temperature?
It has been a relatively slower season this year, I suppose, for hurricanes. John?
Well, the water temperature is actually plenty high enough, and actually we're about one storm behind what we'd normally be at this time of year. We've had 2, where the normal would be 3, but the Atlantic is getting more active now than it was. We've got a brand new depression out there in the Atlantic. I think that'll be a storm by tomorrow, and we're looking at a situation across the Atlantic where I think we're likely to have some here in early September.
Okay, that's right. That was just declared.
That was just declared a depression today, and I think very likely it'll be a storm by tomorrow. Okay,
real good. Well, if you have any questions for our experts, give us a call now at 1-800-327-0945, or in Georgia, 1-800-338-6280. We'll continue to take your phone calls after your local forecast. We're continuing to take your phone calls, and we have in the studio with us our 3 experts. What I'm real concerned about here is that if I'm on vacation in a region and it gets a hurricane warning or something is issued, I don't really know where to go. Wade, how would I know where to go, and where would I go? What would be the safest place?
The simplest thing to do is to cancel the vacation, pack up, and go home. And that's what we advise our people that evacuate during a hurricane. The best thing to do is to go and stay with members of your family or a friend outside of the area. And in the event that that isn't possible, or to go rent the comfort of a hotel or a motel room well out of the area, then local shelters are opened up by the local community, and the American Red Cross do a very good job of managing those shelters.
Okay, as far as the American Red Cross, Don, what I'm concerned about is maybe people think that that's the place to go. Is that where they should go first?
I think if their first option is to heed the warnings of evacuation, in most cases I find that most people will go inland or go visit with families or friends somewhere else. But if you have no place to go, then of course the alternative is to go to a shelter. Mm-hmm. Most of the shelters are inland, away from the coast, what we call in host counties, who will receive the evacuees once there's been an announcement to evacuate. So they're there available for those who don't have relatives or friends who are able to take them in, or they live too far away.
Okay, so that's a last resort.
Yeah.
Okay, we have a phone call right now out of Spotswoods, New Jersey. You're on the air. Do you have a question?
Yes. What are the chances of newly formed tropical depression forming into a full-fledged hurricane and affecting the East Coast?
Okay, I could barely hear that one. John Hope, it sounded like something about a tropical depression forming into a hurricane along the East Coast.
I wasn't quite sure of the question either. I'm not sure whether he was referring to the depression. Perhaps he could repeat that.
The most recent tropical depression, I believe, was
Yeah, well, that's so far out now, it's too early to speculate on whether it might affect the U.S. There is this possibility, but we couldn't say this early.
Okay, so it's a little too early
It's too early to tell.
How many times has it happened where something that far off has possibly come in and affected the coast?
Oh, some of the major hurricanes that have hit the United States have formed right out in that area. The Miami hurricane of 1926, the Galveston hurricane of 1900, for example. David and Frederick as late as 1979, and Allen in 1980.
So it is a possibility.
They all formed out there.
Definitely keep an eye on that one. We have another phone call, and this one's out of Charlotte, North Carolina. You're on the air. Do you have a question, please?
Yes. Can wind speeds be determined by satellite without an actual reconnaissance plane flying into the storm?
Oh, that's an interesting question. John?
Well, we can get a good estimate. We can't tell for sure exactly what the wind speed is, but we certainly can get a good estimate. But we believe strongly that if a hurricane is going to threaten the United States, that we need to get an aircraft out there to measure the winds and to tell us exactly how strong it is.
And there's a bit of a controversy now whether or not the reconnaissance planes will be still going in after this year.
We think we're going to have them. I think Wade has some late information on that. Wade, would you like to speak to that?
Well, yes, we've been very active on the Hill and with the Air Force. There was a move to cancel the reserve units who fly 75% of the missions into the hurricanes out of Keesler Field. It was a budgetary problem. These aircraft are needed to serve as cargo aircraft. We've been successful in preserving 4 of those 12 aircraft. The other 8 will be stripped down and used as cargo haulers. Now, what we're trying to do now is to convince the Air Force to at least lead the instrumentation on those aircraft in order that if they happen to be called back in, go ahead and remove the drop tube, but if they have to be called back in to support not only the defense posture along our coastline, but also the national defense posture. As you know, history tells us that many armadas, the mightiest armadas, have been sunken by hurricanes and not the enemy forces.
Okay, so we still have 4 that we can work with. Okay, real good. Behind us in our meteorology lab, throughout our discussions, our meteorologists are continuing to work on your forecasts. So when we return on Eye of the Storm, our panel will continue taking your phone calls, and we'll investigate evacuation plans for you and your family.
Who've lived through the eye-wall weather of a major hurricane know its true power. For others, it's easy to develop feelings of overconfidence.
Most of us on the coastline go through the fringes of a major hurricane, or we go through a minor storm, and then we form false impressions about what a bad hurricane is all about. Another thing that behavior scientists tell us is that we think we know more about things in life than we really do, if we haven't experienced the worst. And I think that's true in hurricanes.
2 statistics about the coastal population illustrate the problem. Development along the beachfront, such as this, is increasing at a rate 3 times faster than in the rest of the U.S. And 80% of the people who live along the Atlantic and Gulf coasts have never experienced a major hurricane. In addition, there are the millions of people who visit the beaches during hurricane season. Evacuation of vulnerable areas takes 20 hours or more in many places. Here in Galveston, it's 25 to 30 hours. No one can provide that much lead time in a warning.
We're more vulnerable to the hurricane than we've ever been in our history, and it's primarily a people problem, all right? It's because we're locating thousands and tens of thousands of people on islands that historically have gone underwater.
Hurricane strikes are a fact of life along the Atlantic and Gulf coasts. Even Columbus ran across a hurricane in 1494. History since then is littered with disasters, from the Caribbean to New England and westward to Texas. All Atlantic and Gulf coastal areas are vulnerable to hurricanes, but Dr. Frank is especially concerned about several particular places, including Galveston, the Tampa Bay area, the southwest coast of Florida, the Florida Keys, and the islands off New Jersey.
New Orleans, though, has got to be the #1 vulnerable area in the United States. You got the Gulf to the south, you got a major lake to the north, and a huge river through downtown. And a lot of the city is below sea level. And they've got all kinds of levees over there that give people a false sense of security.
There are many problems in trying to evacuate a highly populated coastal area. There are few evacuation routes, some with only 2 traffic lanes. Many of these routes are only a few feet above sea level. That means they would be flooded by increasing waters hours before landfall. Boats would be trying to move inland too. Imagine thousands of cars and hundreds of boats trying to pass a drawbridge. And with high winds, heavy rain, and a hasty evacuation, accidents are inevitable, slowing the process even more.
Some chilling realities to think about for those of you that live in these communities. says keep an eye on them now. As to what they'll do next, well, all we can do is make an educated guess. Here's the final segment of our documentary.
In 1900, forecaster I.M. Klein got on a horse and rode up and down this very beach trying to get people to evacuate. Some people listened, but not nearly enough. Needless to say, the warning system has improved since then.
Bill, do you have the latest recon on?
The National Hurricane Center in Miami is responsible for tracking and forecasting Atlantic hurricanes. They have three main tools for tracking the storms. Until satellites developed in the 60s, hurricanes over the open ocean were often completely missed. All of a sudden, a ship or island would get blasted by a storm. Well, not anymore. Pictures taken every 30 minutes not only detect hurricanes, but show how the storm is moving, help provide estimates on how strong it is, and on how much rain it might produce. As a hurricane gets closer to land, reconnaissance aircraft are sent to fly through the storm. These hurricane hunters take vital measurements of wind, pressure, temperature, and humidity at many levels inside the storm. Finally, when a hurricane is within 200 miles of the coast, radar goes to work. Installed in the 50s, radar gave the first clue that hurricanes had spiral bands. We now have continuous monitoring of the hurricane. When the Hurricane Center feels an area is threatened, a hurricane watch is issued. It's usually for a very large area, alerting the public, media, and local officials to the potential threat. When the threat becomes imminent, a hurricane warning is issued for a smaller section of the coast. Officials try to issue warnings at least 24 hours before landfall, but some come with 12 hours or less lead time. When the warning does come, it implies an urgent need for action. Advanced computer models have helped to improve forecasts and warnings slightly since the 60s, but only slow improvement is expected for the rest of the century.
Now, hurricanes move along in the atmosphere very much like blocks of wood move along in rivers of water. We have rivers of water in the atmosphere. Now, the rivers of water in the atmosphere are different than the rivers of water on the land in one major way. There's no river banks in the atmosphere, so the rivers move.
Look at some examples of actual hurricane tracks, and you'll get an idea of how hard it might be to predict where a hurricane will go. Even if it's been moving on a straight path for days, it can turn abruptly without warning. Here's a hurricane moving northward. It's going to hit the Carolina coast, right? Wrong. It's out to sea. Give the all clear sign. No, wait, it's coming back. Because of forecast uncertainty, the large amount of warning time needed, and the relatively small area getting the full force of the hurricane, many more people are going to be evacuated than appears necessary after the storm.
There's a myth going around in the land today that says that with all those beautiful satellites up there, you must really be doing a great job. And see, every night they see those satellite pictures with their own eyes on the television. And we put them into motion and put them into color. And the myth says, with those kind of tools, you must be doing a great job forecasting. No, no. We do a great job observing. And that we do. There's no question about it. But the satellites do not make forecasts for us. They only tell us what is going on right now.
The weather experts do their best to outline the dangers of a hurricane and where and when it will strike. But it's up to each individual and each community to have plans of action ready in areas affected by hurricanes. And it's up to each individual and community to act on those plans when watches and warnings are issued.
Now, I'm not basically opposed to developing the islands. I am concerned about building death traps. And I fear that's what we've done. I fear that we've got so many people on the islands that our existing roadway systems will not allow them to get back to high ground in the lead time that we can realistically provide in the warnings.
Hurricanes are a part of nature. They help distribute the heat on Earth and often provide needed rain to dry areas. It is people who have moved to unstable beaches and leveled sand dunes. Our love affair with the beach has created the hurricane problem, which hasn't been solved by a few seawalls like this. Since we can't stop these powerful storms, the best that we can do is to learn to live with the threat.
Continuing our discussion about hurricanes with our three hurricane experts, we have a phone call right now of Columbus, Georgia. You're on the air. Do you have a question, please?
Yes, thank you, Colleen. Once a hurricane hits the coast, how far inland will it travel before it dissipates?
Well, Don Stevens, I believe you had some experience in a similar situation with Agnes.
Yeah, well, we did. I really couldn't answer the question in terms of distance, but we do know for a fact that when we're dealing with a storm and a low pressure moves inland, and as it breaks up, that we start, in terms of our preparedness, start thinking about it. It can produce a significant amount of rainfall, which can cause flooding. In addition to that, if the low pressure can produce the thunderstorms, and we know that there's always the possibility of spawning tornadoes, so that's the things we worry about. I thought maybe John could give us a distance or a time.
Well, even though a hurricane's winds will weaken normally after it gets inland, if the hurricane is traveling very fast, high winds can go a long distance. Hurricane Hazel, for example, came in to South Carolina and North Carolina in 1954, and hurricane force winds were observed all the way through Virginia, Maryland, Pennsylvania, New York, and even up into Ontario.
That's quite a distance. You know, Don, you mentioned tornadoes with a hurricane. John, I was wondering if I could ask you, in being from the Midwest myself, I know some hurricanes, or tornadoes rather, can be rather disastrous. Are they the same intensity when they're spawned by a hurricane?
Well, most of them are not quite as strong, but some of them can be very strong. We don't usually see tornadoes associated with hurricanes out at sea, but when they make landfall, they do, and some of them are pretty disastrous, but not generally as strong as the ones are up in the Midwest.
Okay, we have another phone call right now out of Akron, Ohio. Go ahead, you're on the air, please.
Yes, I'd like to know how severe can a hurricane be in the Outer Banks of North Carolina, and how far inland do we have to go to escape?
The Outer Banks of North Carolina, how far inland would they have to go? Who wants to take this one? Wade?
Well, I think we can handle that from a generic standpoint. Any hurricane, the evacuees need to go away from the vulnerable area. The areas along the coastline, the low-lying areas, go inland. And then that's the time to go and visit with family and friends and enjoy the comfort of that good hospitality, or to go to shelter as a last resort.
How about if your family and friends only live a mile or so? I mean, where do you go? Do you head to the hotels?
Quite
20
often.
Miles inland?
Yeah, quite often a mile or so is quite enough. You know, depending on the topography, and that's the key to the whole thing. 9 out of 10 people of a hurricane are killed by the waters, not the winds. It's very difficult to find someone that has been killed by the wind in a hurricane, as a matter of fact. If we escape the area of that tidal effect, where that huge tidal surge comes crashing ashore, ripping and tearing timber and nail, brick and mortar, concrete and steel, whatever's there, there's no such thing as a hurricane-proof house if it's at that low elevation. Just isn't there.
Okay, well, we'll have to keep that in mind. We're going to take a look at your local forecast right now, and after your local forecast, our discussion will continue with Don Stevens, Wade Geis, and John Hope when Eye of the Storm continues. Our discussion on Eye of the Storm swamped with phone calls, so let's head back to the phones. Round Rock, Texas, you're on the air. What's your question, please?
Yeah, I'd like to know why many tornadoes are formed in the northeast quadrant of the hurricane.
John Hope, I know you know this one.
Well, we think they form in the northeast quadrant because as that comes ashore, it comes ashore very early, and the winds are kind of turned inward by friction in the low levels, whereas the winds above 5,000 feet continue to blow from about the same direction, and that creates a lot of instability in the atmosphere, and this is where the tornadoes form.
Okay, and as we mentioned earlier, they still can be quite intense.
They can be quite intense. Indeed, they can. They're usually not right in the eye wall of the hurricane. If you have a hurricane that's 200 miles an hour or even 150, you don't need to conjure up any tornadoes to explain damage, but the tornadoes are likely to occur out a little bit farther away from the center of the hurricane.
That's one thing, too, that we were mentioning before, that not very many people really go through the direct eye of the hurricane. They experiencing those fringes, and I believe we were talking earlier that if you look at the hurricane where it strikes shore, to the left of that area is where it is less intense, and as we saw on the tape as well. Any comments about how many people or how people feel about evacuation as far as that goes?
Well, I think Wade Geis can explain that better than a lot of people. You talk about people who have experienced a full hurricane. We've only had 2 Category 5 hurricanes ever to hit the United States. Hurricane Camille was one, and Wade Geis was Civil Defense Director in Harrison County, Mississippi even then, and he was right in the eye of this, very likely the worst hurricane that ever hit the United States. And he knows what it's like.
Yes. Experience, of course, is the greatest teacher. And people, I think, all along the Gulf Coast, Texas as well as Louisiana and Alabama, have experienced from the tragedy that we've had in Hurricane Camille in 1969. which was probably the most catastrophic act of destruction in the history of the modern world. We're talking about a 25-foot tide with at least a 10-foot sea on top of that. So any way you slice it, that's a 35-foot wall of water that came crashing over this community, ripping and tearing and just laying everything waste below that level. We're not too concerned about the response of the visitor. The tourists are usually the first to leave. Mm-hmm. We're not too concerned about the guy and gal who has experienced a hurricane, who really knows what a hurricane is all about. It's that person who thinks they've experienced a hurricane. They're on the peripheral zone. And they've experienced the peripheral zone of any storm, you name it. They say, well, I'm a veteran of a hurricane. Those are the guys and gals that we worry about the most and that we try to point to move out and get out of that area.
And you do have the authority to go in and say this is a mandatory evacuation.
Yes, we do in our state. It took 7 years to get that legislation through after Hurricane Camille. We did not have forcible evacuation authority in 1969. We do have it now, and I think our elected officials would not hesitate to use it.
Don Stevens, I believe you as well were involved in Hurricane Camille. Did you run into any problems with the people that you had at your evacuation centers?
No, just the normal problems that we always have when you're opening shelters and you're dealing with a mass number of people. There's a lot of people who are upset and you know, they hate to leave their homes, and of course that's what we're trying to deal with in our shelters.
Now, what exactly does the Red Cross do for these people? You know, it'd be very hard to leave your home and know that it would be leveled.
Sure. Well, our main concern right now is just having a mass shelter area for a lot of people. And of course, our concern is to shelter them and feed them at that time, and till at least the storm passes, and then we'll leave the emergency phase and begin a recovery phase based upon the extended damages that occurred in the community.
Okay, thank you very much. Unfortunately, we've run out of time. I'd like to thank our guests, Don Stevens from the American Red Cross, Wade Geist from Civil Defense, and the Weather Channel's hurricane expert, John Hope, for helping us help you survive the eye of the storm. And thank you for your questions and your input. Up next, Dave Watson with your Michelin Drivers Report. Good night. I think it went very well. I think y'all...
And we very possibly are going to have a tropical storm within 24 hours. All right, there it is, and we'll continue tracking it westward across the Atlantic. And who knows, this is the time of year that sometimes these storms continue pushing all the way westward, end up in the Caribbean, the Gulf of Mexico, or moving up the East Coast, and sometimes give us big problems. Not saying that's going to happen, but certainly this is the time of year where that becomes a higher possibility anyway. Here is our depression, the sixth one of the season. It's pretty good thunderstorms around that. It's about 700 miles west of the Cape Verde Islands with maximum sustained winds to 35 miles per hour. And again, the current direction of movement is westbound at about 15 to 20 miles per hour. And again, wouldn't be surprised to see this a tropical storm within the next 24 hours or so. Let's go ahead and put this particular satellite view in motion for you. And as we do so, you can see that area of weather pushing off towards the west. Come on, movement. Well, I knew sooner or later it would have to happen. You can see this moving along from the east to the west only very slowly. Otherwise, we can show you another area of disturbed weather that's just about over the Windward Islands, but that unlikely to develop into any type of tropical structure, simply because what's going on in the upper atmosphere is just simply not conducive for tropical development. A few showers, thunderstorms clustered here and there in other sections of the Caribbean and Gulf of Mexico, but again, no problems anticipated. Here is Lydia, a tropical storm. Maximum winds 50 miles per hour, but as this pushes over colder water, it is likely to dissipate. Typhoon Dinah just skimmed Okinawa with maximum winds, sustained winds of about 110 miles per hour. You can see still a problem. Typhoon, of course, what we call a hurricane.